We should already now have a pretty decent understanding and idea of distance time graphs or displacement time graphs. We're now going to have a look at velocity time graphs, and these I think can in some ways be a little more testing for us, a little more challenging for us. Let's see if we can kind of grasp the idea of what we're talking about. I want to first of all illustrate to you an object which would be moving at constant velocity on a velocity time curve. So, a velocity time graph I should say. So of course, if something's moving with constant velocity, that could be at any velocity by the way, it could be at 0 meters per second or it could be at many meters per second. If it's moving at constant velocity, it means by definition that the velocity is neither going up, that's going down, nor going up, it's remaining the same. So what would we expect to see? That somewhere from some origin point along this velocity curve, we would have effectively a flat line as time progresses because the velocity is constant. So that's a fairly simple one for us. What then would we say, or how would we illustrate a body which was accelerating? So let's see if we can show acceleration. So that is the rate of velocity is increasing as time progresses. So we want to see greater velocity as time progresses. So of course what we're going to find here is that the curve is effectively going to steepen. It's going to steepen. So as time progresses, we are going to get faster and faster at a greater rate of acceleration. And of course, a curve like this would illustrate that. I mean, I have to say that the first bit of this curve that I've kind of drawn in here, this bit here, of course, this little segment here, this is effectively constant velocity. We see it from the curve before. But we now have the illustration of acceleration within the majority of that curve. What, therefore, would something like deceleration look like? Deceleration, again, I would encourage you, if you do want to just pause the video and actually have a go at this yourself. See if you can intuitively grasp this before I draw it in for you. Well, what we want to see here, and I'm assuming you've done that, you've paused it, what we want to see here is that the rate of velocity is decreasing as time progresses. So of course this time, rather than a curve up, we get a curve down. And of course if it goes down steep enough, or far enough, it's going to come down to 0 meters per second. In other words, it's going to become stationary still, right? By the way, if we'd have had constant velocity at 0, as I mentioned before, that of course would have been here, right? Does that make sense? Okay, so constant velocity, a stationary object would be at 0 velocity. Okay, so we've got this deceleration point that's taking place there. And finally, and this is perhaps where the highest level of skill that we need to have is, we also want to have a look at the curve where we might be able to illustrate a change in direction. Now this is going to become important to you in a couple of lessons time when we start looking at the notion of impulse. Okay, so of course what we're going to get here, change in direction, is effectively we're going to get an acceleration in one direction, then a deceleration and an acceleration in another direction. So let's see if we can show that. Well, let's first of all show an acceleration in one direction. So we start moving in one direction, perhaps upwards from a jump. We start to decelerate. And now we decelerate to such an extent that we actually start moving in the opposite direction, and we're there. So effectively what we've got here is we've got two forms of kind of acceleration. We've got one form which is kind of the positive velocity which is taking place here. Okay, this is maybe what we consider to be the positive, and then we have another here, which might be considered to be the negative acceleration. So for me, this would include something like jumping and landing. Okay, so it could be something like jumping, and landing. So what we've effectively got within this illustration is that the performer starts to accelerate upwards at this point here, accelerating upwards in that direction. But of course, when they reach their peak, they stop accelerating upwards, as they slow their upwards movement down. They stop accelerating upwards and gradually start accelerating downwards, back past the kind of the neutral point where you kind of lower as you land. You sort of dip down lower, don't you? And that is illustrated by this part of the curve over here, that kind of braking impact of lowering yourself on the landing phase. It could equally be, someone runs in one direction and then they turn and go back in the other direction, right? It could equally be something along those lines. That's all from me. Thank you for taking part.